ladies and gentlemen. My name is Annelien Tischendorf, and it's my pleasure to welcome you today to the workshop, Standards in Action. Today we will have a hybrid meeting, which means that we have present physically here in the Flowers room, but we also would like to say welcome to everybody online who will be joining us virtually. I would just like to give you a few administrative points before we start. We have a very, very tight program today with lots of interesting projects to be delivered to us. So we would like to ask you, if possible, to please keep your questions to the end of each section, if possible. We will also make some breaks in between if you would like to take a smoke outside or have coffee, just stretch your legs. Today's workshop will also be video recorded online, but we will also make some video recording of this session here in the Flowers room. So if anybody objects to being on photo, we would ask you to please look at that to the side of it. Good. We have two speakers that we would like to welcome online. The first is Peter Kostler. He's our committee chair of the ISO Technical Committee 211. And the second is Simon Brecher, which is the leader of the outreach group.
Peter has another meeting, so.
Okay. Well, then Simon will give us a welcome.
Hello, good morning. Can you hear me?
Yes.
Because the sound here is a bit, we cannot hear you quite well on the Zoom. But anyway, good morning to Vienna. Guten Morgen nach Wien, dobro jutro na Dunaj. It's a great pleasure today to, let's say, to open this edition of the Standards of Action seminar, which was which is one of the first that we are again organizing live after a few editions that we were forced to have them online. I'm very sorry that I cannot be there because of the other obligations I have at the moment. But as Standards in Action seminar, usually that we are holding during each of a plenary week, in which we are trying to show with all the presenters and speakers the best use of the standards that this committee is providing in the practice. So our Austrian colleagues from Standards Austria had put a lot of efforts to prepare a very rich and, as already said, tight schedule and program. And I would just like to be short and wish you to enjoy with all the presentations in the program. And also wish you a pleasant plenary week of ISO TC 211. So that would be everything from my side. So enjoy with the presentations.
Thank you. I will try to speak a little bit louder so that the Zoom meeting also picks up the sound. Good. Our keynote speaker of today is really a giant in the GIS and geoinformation community. Professor Bartelman is a retired professor from the University of Technology in Graz, and he has been involved with the standardization process, both on national level in Austria as well as on international level in the CEM and later in the ISO over the past 30 years. In his keynote speech, he will address us today and reminisce a little bit, thinking back about what happened over the past years concerning the international standardization. And he will also give us some insights from a very personal level. Thank you.
Thank you very much for the friendly words, Annelien. Good morning, ladies and gentlemen. I'm very happy and also honored to give this first speech in this arena here. And 3 this will appear in several of those slides, also about those 3 days standardization, but also from the personal level. So in short, you will see all this, what I mean about 30 years. geographic information, the beginnings of standardization, the first plenaries of ISO TC211. Also a few words about Austrian Standards International, which is hosting this meeting here. Then it fits very well that the Vienna Agreement is also 31 years old. Talk about this, also about the OGC Cooperative Agreement, and some other embeddings and liaisons. So what is a generation? You all know, in a family, we talk about 30 years approximately, but there are other definitions for generations, like social generations, the baby boomer generation, the 68ers, the millennials, etc. We can also talk about GIS generations. If we look at it in terms of devices, first, second, fourth generation, from mainframe to desktop to mobile. In terms of connectivity, from standalone to fully web-based. In terms of usage, from single use to fully interoperable. And we can also talk about generations in standardization. Starting with awareness, which is probably the most difficult things to achieve, to get people aware of the need and the benefits of standardization. Then there are individual provider-client agreements. Then we proceed to formal specifications, and finally to standards. Yeah, and here you see all those 30 years and plus minus a bit, 31 years Vienna Agreement, 30 years CEN-TC Geographic Information, 287, almost 30 years of our current committee, almost 30 years of OGC, Open Geospatial Consortium, and 30 years of my personal involvement in standardization. So what is the common thread through all this? The concept that stands behind the whole thing is information transfer, which really cannot be enacted in fully, but we can only transfer data. So we have to rumble up information into data, create a data stream, and reconstruct this data stream again to information. And as the graph shows, misunderstandings can happen and will happen. So we can say standardization is a means to minimize misunderstandings between sender and receiver of information, although we never can eliminate it, but we can try to make it as small as possible. Geographic information, geographic data, is only a specialization of this. So if you look at this graph, you see a lot of data, those are the pixels in colors. But the information is far more complex, and probably every one of us extracts a different type of information from these data. We see our conference venue, and we see the buildings, we see the highly developed urban area, urban fabric. We look at transport possibilities, public transport maybe. We look at parking lots, maybe we look at coffee shops, etc. So we all have different needs for information which are being conveyed by the same type of data. So where did it all start? I'm very happy to see Olaf Østensen here in our audience. And for me personally, it all started in Vienna, in Norway, 30 years ago, when we were invited to join the working group 2 of CEN-TC 287 at the Barilla Hotel, very beautiful mountain resort. I remember we were snowed in for 1 or 2 days, which was also a benefit because it forced us to talk a lot and to get to know each other. And many of those people who were there present at this meeting later on also arrived at ISO TC 211. So it was a tight-knit group from the beginning, starting with this meeting chaired by Olaf Østensen. Well, Olaf, only 1.5 years later, became chairman and convener of ISO TC 211, as we all know. And the work just proceeded into this path. Also on this picture, you see a lady which many of us know still, Vienna. She was for more than 20 years the heart and soul also of this group as a secretary. And we tried to reach her and we succeeded, and I asked her if we could have some photos, and she has taken many photos in all those ISO conferences, and she gladly agreed, and she said I can use any of those photos for my presentation, which I do now, and also later on during the coffee break outside there will be a slideshow with those photos I received from Vienna. Yeah, those were the first meetings, starting in Oslo, Dresden, so South Korea, etc. You see in red also a meeting in Vienna. We already convened here many years ago, too many years ago, so I'm very happy to be able to greet you again here in Vienna at the 54th meeting. But you see, a lot of it happened in between. So at the third meeting in South Korea, Jensi, Olaf Östensen, and Björn Zetteroy, together with François Saget, John Rowley, François from France, John Rowley from the UK, at the resolution committee meeting at the end of the plenary. Another long-standing member of our group, Ken Bullock from Australia, and Björn commented all those photos very nicely, and he said we still used landlines back then, so it was interesting. You see how technology there was a fast development, but still the main thread of trying to avoid misunderstandings in information transfer was the same, but with different technological means. So now we have 19 published standards. Take this from the official ISO TC211 homepage, and 23 still standards under development. It's an ongoing work. It will never be completed. You can see this as a drawback, but I would see it as a benefit. It's something living, very alive, and it's interesting because you're always at the front line of technological development. We have 37 participating members and 33 observing members. The Secretariat is currently based in Sweden at the Swedish Standard Institute. One of those members is ASI, Austrian Standards International. And I won't read all those texts here, but you can, I'm sure you can read later on, download these presentations and see what it says. So ASI is like its sister organizations in other countries. The constituent members of ISO and CEN, so it's sort of a tree-like structure. Experts coming from those national standards organizations partaking in meetings on the ISO level and CEN level, creating standards that go back to the countries again. In Austria, those standards are called ÖNORM standards, mostly by the population. DIN standards in Germany, AFNOR in France, etc. I already mentioned briefly the Vienna Agreement, because we celebrated the 30th anniversary. It is not an agreement only for geographic information, but for all of ISO working items, very important, because those two organizations want to collaborate. The objective is ensuring that European and international standards are not in conflict with each other, but rather are as consistent as possible. One standard, one test, accepted everywhere for a lot of advantages we all know about. You see the three proponents of CEN, of ISO, and of Austrian Standards International, as they celebrated this year, I think it was in this building 31 last October. Here is a view graph of the late Hans Knoll, a very well-known, renowned expert in standardization from Germany. He described how ISO flows into European norms, into national standards, and finally gives rise to technical standards and guidelines. CEN and ISO are not the only collaborations, but we have also a collaboration between ISO, TC211, and OGC. They all have the same goals, but different priorities. ISO is more on the formal level. OGC, Open Geospatial, is more on the implementation level. So we have two sides of the coin. Both sides are important, and both sides try us to get in conflict with each other. So this collaboration is also, well, it's not 30 years old, it's 25, but yeah, all of those things are fairly long time already. The first ISO standards, you see them here from a general reference model, to details about conceptual schema language, terminology, a very detailed spatial schema, temporal schema, to spatial referencing, and important also quality principles and metadata. Here at the meeting at Victoria in Canada, Björn gave a comment, more and more laptops appear. So a change in the technology, but the same goals. Because of developments in the technology field, we have now imagery and grid data, which was not present in the first 15 members of this family. We have where is this escape button? So we have imagery and grid data. We have the advent of the web. So we have web services, WMS, WMS, WFS. We have location-based services because mobile devices became apparent and far more and more important. We have, just to mention one other thing, an ontology here on the right side. So things that together with formal development in the technological field also entered our standardization work. Another meeting, everyone had a laptop. Here in Vienna, that was the last meeting we had in Vienna. Well, not everyone, if you see Austria in front, the space is empty. We have the benefit and also the obstacle that Austria is the first in the alphabet, so it's very apparent if somebody is absent, but I can say it's my excuse. We had some organizational work to do here, so that's why I was not on my place here. Coming back to the main thread of this standardization, I can ask the question, is there any information that cannot be related to a place on Earth, that cannot be referenced, georeferenced, be transport, be climate, economy, agriculture, property, politics? Everywhere is geo-information, geographic information. If it's not yet georeferenced, it could be and it will be in the future. So geographic information is ubiquitous. And because it is ubiquitous and it enters all of our life on several areas, there are very many contacts, overlaps, common interests with other fields, and therefore numerous liaisons, as ISO calls it, with information technology, computer graphics, image processing, building and civil engineering, geodesy, intelligent transport systems, environmental management, sustainable cities, smart community infrastructure, etc., etc. And you see the organizations that are in liaison with ISO TC211, European Space Agency, Food and Agriculture Organization of the UN, ICA, International Cartographic Association. I cannot read all those names now, but you see it's wide spanning. Some people always say, well, you do standardization work, well, that must be tiresome and tedious and dull. And I say, no, it's not. It's not dull. As this photo proves, so it can be very lively and entertaining. It's alive and it's lively, so it will never stop. It will go on and on with technological development. It's not the end point of an advancement, it goes hand in hand with it. And it provides an impetus for the search for new horizons. You complete one step and standardize it, and then you have appetite for the next step. So it goes on, and this is also something very positive, I think. We can plan new adventures, and as I said, it's a lively thing to work in this standardization area. As also this last slide shows, also from Germany, standardization rocks. And again, it's a photo from Vienna, from this last meeting in Vienna. This was in March, beginning of March, so you still had an ice skating ring in front of the city hall where you will meet tonight for the Gardening Day, but there is no ice skating tonight. But I sure hope and I know that we will have fun together. So thank you very much for your attention.
Okay, ladies and gentlemen, on the program we have a 5-minute break. Shall we proceed or shall we take a break? Okay, I think we're going to continue. Good. We come to our next section, and this is the Austrian governmental services based on GIS standards. Now, the next project that we are going to present to you, I'm not going to give away too much, but it is the most widely used open data product of Austria. And to present this to us today is Wolfgang Jörg from the Vienna City Administration. Just a few words. Wolfgang obtained his master's degree in cartography at the University of Vienna in 1991. And since 1992, he has been employed by the municipality of the city of Vienna. Initially, he was responsible for GIS applications and programming, and for the past 15 years, also for the coordination of GIS in the city of Vienna. His main tasks include governmental geodata and services, also open data, and he is a member of several of the national GIS-related committees. Today, he is here as the project manager of the project basemap.at.
Thank you. Very warm welcome to all of you. And I will talk about the basemap.at. First of all, let's go back in history, go back some decades. And the city has a very long tradition in digitizing. It was in the year 1974 when the city of Vienna bought the first fully electronic digitizer in Austria. And as early as 1979, the first computer city map was not yet fully automatic. In that time, the Austrian administration started to capture geoinformation in a structured way, not to produce beautiful maps, but to optimize their administrative tasks with the aid of digital geodata, to make them more efficient and effective long before the internet was invented. When the GIS software was put on the market, we began creating our own Vienna GIS brand in 1990. In 1995, as internet began to spread, the Vienna city administration was the first in Austria to provide an interactive online city map. The original map was already capable of delivering a live calculation of whatever map section users chose to see via the remote procedure called info. In 1999, we developed our own webmap server. In the year 2000, we started the first webmap tile service, which was one of the first worldwide. 10 years of experience with OGC and ISO tier standards. It was in May 2011 when the city of Vienna launched the first open data portal in Austria. Many recommendations from numerous organizations, from federal and regional administrations, and the vacuum of a detailed, up-to-date, and totally reusable basement of Austria led to the birth of basement in November 2011. Since January 2014, the raster basement tile cache with webmap tile service is in production. And in 2019, we launched the webmap tile cache based on the Webbox 2.0 specification. Basement is the administrative basement of Austria and still the most used open government data product in Austria. Basemap.at is the result of the cooperation of the 9 Austrian provinces, Institute of Transport Infrastructure, University of Technology, Vienna, and the company Synergies. And the project was co-funded by the Climate and Energy Fund through the program for innovation, green and efficient mobility. We also could partner with the Austrian Association of Cities and Towns. The making of Basemap, so we had a spatial merge of the decentralized geodata of the 9 provinces. And Basemap is a cartographic product completely based on administrative data like addresses, streets, buildings, rivers, lakes, terrain, and so on. It is updated bi-monthly according to the data updates from the partners. And from a technological point of view, it's a raster tile cache based on the webmap service here, and the G service is the webmap tile service, which is conform and compatible with OpenStream and Google Maps, Bing Maps, and so on. Let's talk about the different basement products in addition to the basic, the standard product upper left. We offer a color reduced version, transparent overlay containing streets and annotations, and a so-called high DPI version, which corresponds to the standard product and has twice the resolution, and therefore it's perfect for retina displays, smartphones, and so on. The scalar range is up to 1:1000 for whole terrain of Austria in some regions like Vienna, Linz, Graz. Scale is up to 1:500. That's level 20, which is the tile cache specification. In addition, we deliver a basement orthophoto product, which has a resolution of 29 centimeter, which corresponds to level 19, and some areas 15 centimeter, which corresponds to level 20. I want to point out the yellow box you can see in the slide which enlarges the water prints in the map level 17 and 18, showing the area live. So you are always informed about the date of the original photos in a very easy and fast way. If you are searching for basement.at access points, join the basement homepage or the open data portal of Austria. So some facts. We have a lot of, I would say, thousands of applications using basement.at, and we have more than 100 registered applications on the open data portal of Austria. There are about 30 million requests per day, download volume about 500 terabytes per year, and the production update and hosting is done by the city of Vienna, done by our department here in Digital, Municipality 1, and the data storage is the cloud storage of the city of Vienna. Finally, I will talk about the challenges for the future. The raster tile cache is very simple, as you know, and clear, but vector tile cache is much more complex, and there's space for individual implementation. So it would be a great advantage to have one clear standard for vector tile cache in the future. And the second challenge is the total engineering of the production workflow away from monthly update towards daily update, respectively real time. For this, we start a pilot project in the next months. So that was the presentation. Do we have 2 minutes less? Maybe I can go online. I will try. So let's go. I will start the basic homepage. And I have to share the screen. Okay, now you can see the homepage of basement.at. There's English version. Here's the web button where we have a simple web client. Where it works. Okay, it's a little bit slow. I will point out the detailed information. For example, we have in Vienna, and if we go, if we zoom in, for example, in Zentralfriedhof, you can see the grave numbers. So I think that's outstanding.
Very important in Vienna.
We also have different information in other regions. Also, in the cities, the whole official address register, official intermodal street network. We will have a presentation afterwards, and so on. And the vector tile cache for all of this data is about 3 gigabytes, and the raster tile cache for each program is about 150 gigabytes. So that's the difference. Okay, thank you very much.
Good. The next presentation today is from one of our sponsors, the company Synergis, and I welcome to the podium Mr. Gerhard Tusch and Stefan Jacquemart.
Thank you so much. Welcome to you join here in the room and also online. First of all, I want to say some greetings from Satish Tankaran from SRE. He's sorry that we cannot be here on site today because still travel restriction and also organizing all the stuff that's starting up after COVID, it still needs more to be done. So it's my pleasure to replace him here on stage and talk a little bit about Ezra. I don't want to introduce Ezra too much because I'm pretty sure everybody in the room knows pretty well. But as you know, ArcGIS is an open platform. The product portfolio is implemented with a lot of standards with other different applications. We will also have one practical example from Austria later on. But this is one of the most important things from the Esri point of view, that we are discussing and explaining all the time to our existing customers. We have to leave our silos, and standardization is one of the old door opener to get interactive with other systems and other kind of data, and that's important for the whole development of fully implemented application frameworks. Esri is playing an active role in all the standard organizations. We have active memberships in the ISO 211. The OGC, the W3C, and also the IHO. And ArcGIS is also a long tradition and certification of the OGC standards. At the moment, I checked this recently on the weekend, about 162 products being certified. We have 437 standards implemented, and all of them are currently compliant. And I also checked it because we have heard a lot about history. So the first OGC certification was done shortly before Christmas in 1999. So in the last century, so the whole story is very important for us for a long time. We are supporting the open standards across the whole ArcGIS systems. So because of the whole data lifecycle to produce data, to publish data, to collaborate with this data, with data from other systems, and more important, as shown by Wolfgang before, to share this data in a standardized way for other applications. And in the end, the most important thing, to get the data being used. Because have the most important data just in-house in my own silo, it just half the way. We need to use this, open this data for the usage for everybody. So you see on the bottom right line, all the application from the Esri technology stack, from the desktop ArcGIS, over the server components, and also the software as a service application ArcGIS Online are supporting the different kind of data standards and functionality standards that are out there. I don't want to go through all of this. I just threw out two of them. The first is the ISO Plan Administration Domain Model. It's a data model that's proposed by ISO several years ago. In the meantime, there are about 40 local countryside implementations utilizing this model. And this is a functionality model, but Esri is supporting this land administration domain model, utilizing the topology, the cadastral fabric within the ArcGIS product portfolio. So you see here a technical implementation of the land administration domain model utilizing the ArcGIS product suite. The most important thing is not only focusing on supporting the standardized here, but I can really use the same kind of data without any ETL processes in all the standard ArcGIS product portfolios, like you see here, a web mapping application or a modern dashboard, where I can really use directly the data supporting this data model directly within the product portfolio. But we're not only focusing on cadastral information, because over the last year, a lot of development has been done in the 3D environment. So the second step to the I3S standard from OGC, where all the 3D data types could be supported as a data stream over the web. I choose here one example of a building to see about the functionality possibilities, that we don't focus on GIS only on the land coverage, but also to have the possibilities to utilize the same technology, the same functionality to go inside the building and to open again a very important connection to the BIM world, to the building information management world, because this is also two domains that have to be linked together. But not only buildings are supported by this, I forgot this one, and IFRS is a standardized, is used already by many different vendors to provide their data to their customers, and have this data stream with this open geo standard. But this IFRS is not only used for data streaming, but also inside the Azure technology world, again, have done a lot of development work in the area of artificial intelligence and deep learning. And so utilizing the standardized data stream IFRS as a basic to do all this deep learning and artificial intelligence, like you see here, the mesh segmentation or point-to-point classification are based on the standardized services. Not so much about the technology. Sorry, my voice is not that good today. I hand over to my colleague Stefan Chetmar, and he will tell you about the implementation example of the Bluebell plugin information system.
Hello, welcome. I want to present a very simple example project which was done in the Upper Austria region from Austria. And we have two project partners. Here is the regional government of Austria. It has a GIS department called Globus. And on the other side, we have a company called Elementarsche and Präventionszentrum. It's a center for disaster prevention. This EPZ addresses all meteorological and natural hazards with focus on hail and flash floodings in terms of prevention. So it supports with the information of this data and helps on analyzing this. What is flash floods? Short introduction was the topic. Flash floods occur if in the soil is already too much water, it can't access more water, and additional rain or snow, melting snow, leads that the water can't sink into the soil and floods the area, often urban areas. Flash floods have to be distinguished from fluvial or coastal flooding. So it is really important to get some information on where can this occur, and so the EPZ created a fluvial flood risk information map. It's a 2D hydraulic model with a 1 meter resolution. It shows areas with increased risk, and it's basic for urban planning, or if you want to build your house, you can get buy some area, and well, then you get informed how does this area look like. And of course, it's not surprising that the data that is interesting for insurances. So let's move to the more technical side. In this project, standards was used, and it really helped a lot. We have on the one side the EPZ infrastructure. EPZ provides the flash flood maps, which it has a GeoTIFF or a cloud optimized GeoTIFF. It provides this as a WNTS service using GeoServer open source. On the other side, we have the Upper Austrian regional government, GORIS. It uses ArcGIS Enterprise for the GIS services. It has internal clients, and it has also public available web clients. And now they want to use data from EPZ, which is easily done if they use the WNTS standard. Additionally, this is no data that is public available for everyone, so it's secured, it's over IP range secured, and all clients in the Upper Austrian infrastructure, they can use it. But additionally, the public available web client can use it too. And well, this looks like this. They have a product called Web Office from the company Verticus, and you see, the map showing that you have the possibility to get the information on your area, how big is the risk. So, but on the next step, the EPZ provides this information for business customers, for insurance companies, or whoever wants to pay, and with the price. So you can, after you get the access to the system, afterwards you can define their client, it's a client from Energie Steiermark, and they say, okay, I want a specific area, want the information, and they have to pay for this area to get the data. It's important that not everybody can use this data because it really needs professional expertise to interpret the data correctly. So this is just a very simple project, but a good example how standards are used and help implementing interacting projects.
Okay, we seem to be making very good time at the moment. Everybody's sticking to the timeline. Next, I would like to welcome to the stage Hubert Vienna and Sarah Lena-Kordash, both from the City of Vienna, Department of Surveying and Mapping. Okay, we just heard that Mr. Lena is unfortunately not here today, so Mrs. Kordash will present on her own. Just to present her, I would like to say that she works, as we said, at the City of Vienna, but she works in the Department for Innovation at ICT, and she's one of the projects, Digital Twin and Planet Twin, and she will explain a lot more about that.
Thank you. So I will present 3 projects: Digital Twin, Planet Twin, and Visa, and how they are linked within each other today. First, in general, before we go into the topic, just one slide regarding the vision of the digital twin. Of course, a digital twin, the virtual space, can only be built if we gather the data from the physical space. But if we are in virtual space, we can carry out simulations, analysis, and much more. And through that, we gather information for the real world. So, coming to the first project, the Digital Twin, it's a project we started at the Department for Surveying and Mapping at the end of 2019. And maybe you're wondering, because it's not the digital twin as you do it nowadays everywhere, but it's the digital geotwin. So what does geotwin do? As I already said, we are a department for surveying and mapping. So we provide the measurement data for whole Vienna, from terrestrial surveying, from photometrical surveying, mobile mapping systems. We will hear a presentation about that data and point clouds and so on. And we gather that information in 3D. So our goal is to build a semantic vector-based 3D city model from whole Vienna based on our 3D surveying data. If we think about the history, 3D city models were mainly only based on buildings, but in the geotwin, we don't only want to cover buildings, but really all objects within the city: vegetation, streets, city furniture, water beds, and so on. So it should be this virtual replica of the city. And our third goal is, because we also provide all the geodata products of the City of Vienna, to derive the city map, different the city models in their level of details, the height model, surface model. All that information should be automatically derived out of the digital geotwin, and that also provides that the geodata products will design and content for you. Good. As we talk about standards today, the digital geotwin, of course, has to be based on a data model, on a semantic data model. Therefore, we use HTML in the version 2.0. Just short, what were our requirements when we chose the data model? it needs to have the possibility to include all objects of the city, so not only buildings, but all object classes that were defined in our object catalog. And it has to be, of course, an open geospatial standard. And just some key facts regarding CityGML, it's an open data model and also exchange format, XML-based for semantic 3D city models, and it is an OGC standard since 2008. This year, CityGML 3.0 finally has been released, but it will still take some time till all the applications use CityGML 3.0. That's why we decided to use CityGML 2.0. And one important aspect as well is because the object catalog of every city is different, so there needs to be the possibility to extend the CityGML data model regarding our use cases, and in CityGML this is possible by the application domain extensions. Here just a short picture to show you that CityGML really covers all thematic modules. So there's always the CityGML core, and then you have all modules from buildings to water body, vegetation, land use, and so on. And of course, additionally, ADIs as well. And just short regarding the concept, the CityGML structure always talks about the feature itself, so the physical entity like the building or the tree outside. And this entity is then represented by geometry through shape application. And in CityGML, we work with multi-LOD level of details. This means that one object can be represented in many different levels of details, from a simple 2D surface up to a house with an inside modeling. In CityGML 2.0, in CityGML 3.0, there's a new concept, but I won't talk about it. Good. So that's the GeoTwin. Now coming to the planning twin, what's the difference and what's the link between those two twins? So as I already said, the digital GeoTwin is this virtual replica of all existing objects of the city cycle inventory. And it has the basic information regarding the objects collected from the scale and the geometry of the objects. But we have also defined some use cases to make sure that this GeoTwin can be embedded into a digital twin of the city of Vienna. And one of those use cases is the planning twin, where we got some innovation funding last year. So what is the planning twin? The planning twin integrates planning data into the GeoTwin, into the existing city, and represents the virtual image of the city's future. And through the planning twin, we want to provide central support through the whole stages of the planning processes. If we think about planning processes, there are big planning areas within the city, like Asia or small building plots. And through the planning process, there are many planning stages that are being gone through, like from simple models, cubatures, up to detailed urban planning models in 3D and 2D models. And of course, regarding the stage in the planning, these data sets have a different detailing as well in the geometry and also in the attributes. And there is no standard for planning data, so there are many different 3D data formats used within this planning process, and commonly there mainly have to be ETL transformers used to transform and to work with this data or to integrate the data into an existing city, for example. And that's where I'm coming to our third project now. It's the project RISA. It's not in the Department of Surveying and Mapping, but we are presenting it today for our colleagues. And RISA is somehow this last step before the construction of a planned building, and is so the link between the planned twin, where we have the planned objects, then the construction is coming, everything fits into the building block, and then when it's built, we are measuring it in the surveying department, and it will be part of the GeoTwin of the inventory. So PISA stands for Building Regulations, Information, Post-Emission and Movement. It's a very big project within the city of Vienna. And its big vision is to increase the efficiency of construction submissions up to 50%. Also, it has a very pioneering participatory approach, and the human should be in the center of the digitalization. So, what are the three main goals behind the concept. The first goal is to partially auto-check 3D model submissions based on BIM. We will hear about that more very soon. And furthermore, artificial intelligence enables auto-checks of legal framework conditions, documents, and also digital support. And also augmented reality is being used to enable the visualization of the construction projects that have been handed in. And the project has been funded. It's an UIA research and development project funded with nearly $5 million, 5 million euros. And it has also already gotten an award last year, and it was the administration award in category Innovative Service Design and Digital Services. So let's have a look into our most important goal of the project. It's the partially auto-checking of 3D model submissions based on BIM. So we have two important topics in there. The first thing is the building application model that is handed in by an architect, for example. And this building application model contains the 3D model of the construction project and is handed in with a surveying plan altogether as neutral IC file, where we have another standard that we will talk about very soon. And this file is also used for structural inspection in advance. And then we have the REM, it's the reference model. And this reference model is automated converted out of 3D surveying plan. And furthermore, this reference model also fetches the actual building regulations via artificial intelligence. And here you can see how the reference model is being created out of the surveying plan. And then those two are checked against each other. So the REM, the reference model, somehow forms the shell against which the BAM is checked under the consideration of the building law. And here you can see how those checks are working. And if the building application model fits into the reference model, the result is positive and the construction site can be. And second standard for today, as I already mentioned, the BAM is based on an ISO standard IFC. What is IFC? It's the Industrial Foundation Classes, and it's an ISO standard, and it's same as CityGML, also an exchange format and a data information model. And compared to CityGML is a standard for 3D city models, and IFC is the standard for the exchange and description of rich and fine-scale building and infrastructure data. But IFC standard, it has also already been extended to provide construction details on other thematic modules as well. And we can think about the thematic modules I already mentioned at CityGML some slides before. So the two interesting topics for us when we talk about IFC and the PISA project are the level of geometry and the level of information. So the level of geometry tells us the degree to which the building or the object has been specified regarding the geometry and attached information. And the level of information tells us the information density of this object additionally, like alphanumerical or supplementary documentation that has been delivered. And within the PISA project, the BAM demand has been defined as LOG and LOI 300, which means that a construction project needs to have elements that are defined with their exact dimensions and also their relative positions with that position. And the level of information tells us that all those reached in construction projects need to have additional attributes regarding the quality and also the requirements like surface, materials, soundproofing, fire protection, sustainability classification, and so on. And these information has to be delivered with the building application model that is checked against the reference model. So to make a conclusion, how are these projects now linked to each other? So the GeoTwin is currently our build city, including all its objects, and CityGML LGT standard is used therefore. The planning twin is our future of Vienna, so the virtual image of the city switcher, but there is no standard yet for planning data because there are so many stages and different PD formats. So maybe ETL is being used for the handling of the data. And then LISA is partially auto-checking this 3D data that has been handed in during the planning process. and therefore the ISO standard is being used. And if this check is successfully, we can then build, not we, but the construction is gonna build the building or the object. And after it has been finished, it is inventory of the city, the surveying department will measure it, and then it will be modeled within the digital twin of the city again, and the circle will be started from the beginning. Thank you for your attention.
Thank you. That was a very interesting one. We now actually have a 15-minute break. So I suppose we will meet again just
Discussion.
if there's any discussions, yes. Is there anybody that would like to maybe mention some projects that they've already seen? Some questions? Online, let's have a look. So, there's someone in the chat. So, because you were all very, very good in keeping with the time, we will have a little bit of a longer break now. You can all stretch your legs, have some coffee, have some discussions with your colleagues, and we will convene again at 11 o'clock. Thank you.
The next group we have something.
Okay, will you join some of the Spanish work?
Yeah, I mean, I'm already I don't know.
Well, welcome for people joining the meeting. Do you roll up now?
It's hard to
There, no. I worked with it was actually They have never been active. Mapping theory or something of the same in German is the government level is there are lines between the information that why should there be this regulator within it? Probably will remain so. It was interesting. I was quite interested also about interesting this combination with human IFC. That's kind of one debate in ICT level, and we have had quite good cooperation with Smart International. We are bridging between us. So but it's hard. It takes some time. I think that we have joined with IFC. Provide information on every window handle and things like that. That's a bit different level than any longer with everything that's going on. The banking agency is hard to get all that. It's very interesting. This is a digital that's come out, which is really the same idea we have been working on since 30 years back. It's really a digital tool we have been trying to establish. I'm not using that, but ironic that that has got interest with the high-level management of the navigation people. While I did never understand what they were. They allowed it. They had something behind it, but they were never really interested. As far as I understand. Yeah. Now I learned that instead of using your hands
Yeah.
The European location framework for Vienna, which I coordinated, ended in 2016, last big sites in the ISO. lab services. Getting the right views, going with them. At some level, I think they announced that they want to be in-house level. But that was charged over the communications under the AI. I don't know what happened now. Down the drain, I guess. Like many European projects, European funding projects, they have a lot of plans, then afterwards, I don't know. I don't know about the pension scheme. I know what I get every month.
Okay, we're a little bit past the time at the moment, so we'll have to make up again. But before we proceed, I would just like to say a very, very welcome thank you to all our sponsors for today, and not just today, but the whole week apparently. They have also provided us with sandwiches and snacks in a room, which is down the corridor. I'm sorry that I did not tell you this before, but please in the next coffee break, all go ahead. There's a lot of snacks and coffee and sandwiches for you to enjoy there. The sponsors for the whole week is Data, the Vienna Synergist, Dural, Spatial Focus, Magis, Video Gis, and the Shut V. We come to our next presentation. Now, please give them a Good. The next presentation is called Kapatsume, and it's a very interesting project that will be presented to us. It's digitizing Vienna's urban spaces with the use of millions of laser scans and images. And responsible for the technical implementation of this very big data project is Lothar Eisen from the city of Vienna, Department of Surveying and Mapping. Lothar is the deputy head of this department, and he also heads the unit for innovation and ICT staff. He has a technical background in field surveying and geomatics, and he holds a PhD in photogrammetry and remote sensing. He's an innovator in surveying and mapping sector, and he drives new digitization methods such as artificial intelligence based on geodata, as well as mobile mapping, where we use 3D data collected from vehicles and aircraft. Thank you.
Yeah, thank you for the introduction. I welcome everybody here in the room and also on the digital. So the next couple of minutes I will tell you about the Kapatsume project that we do in the city. Thank you very much. It's about digitization. Okay, everybody should hear me. So first of all, start off, we did 2 mobile mapping campaigns in the city. This means that we had a lot of cars driving around with sensor technology, and this whole digitization task was encapsulated in a project which is called Traum. I won't go too much into detail, but there's a link up there, also a QR code where you can then afterwards read about this project. And you already see some images about this car with the sensor technology on the roof. And basically, it's about digitization of public space. And to get an insight of how this works, I have a video on the next slide. Let's see if this one works. Yeah, here we go. So you will see there's mobile mapping cars. So those are the ones from the first campaign we did in 2017. You will see the sensor setup and how the data is collected. So you see that there are cars with a lot of technology mounted on the roof. There are cameras which are calibrated using, I think it's a nice standard with the Siemens Star, for example, to get the camera resolution and the calibration of the systems. So it's all geodetic hardware that is used. And after calibrating the systems, the cars go on the roads. They collect the data while driving in the normal traffic. And the data is collected from cameras, from laser scanners. And as you can see, the car is now passing by the mayor's hall, where we'll be at the evening. The car also sees a lot of sightseeing, as you say, because it covers all roads in the city. And after collection, the data is then processed to be able to view it in a viewer system. The quality is checked, the data is analyzed, we do georeferencing of the data. This means that the data is really positioned at the correct spots. And you end up with a digital service, as you can see here, where you can move through this data set. You have a map where you can position yourself, and in the background you see again the mayor's building where we will be for those who need it. So this is the task, collecting the data and then putting in the data into a digital service. And next part here, a little bit more into detail about the sensor technology. On the right hand side, you see this car with sensor technology mounted on the roof. Basically, it's a camera system with a high resolution and a laser scanning system, and those 2 sensors are moved across all the roads in the city of Vienna. And to name some numbers, so it's 4,600 kilometers of road network that is covered by these cars. It takes about 3.5 months to collect all the data sets. And as I mentioned, georeferencing is a big topic for us. The data will be moved to the correct positions through a number of 10 centimeters. And so this is really necessary then to be able to use it for GIS and surveying tasks. And a lot of images and laser scans are collected. And as you can see down here, it's a lot of data that is collected. It's 160 terabytes when the data is processed for the systems. So it's kind of like a big data project, and we handle this data. And basically, what's coming out of the data collection are images and so-called laser scans, which represent 3D information, which is georeferenced to this 10 centimeters. But the question that we have is, how do we get this good quality because there are a lot of sensor systems around the world, and how do we get this quality that we really need for our systems. And what we did is we kind of like developed a performance evaluation using test charts. We did this together with the University of Technology in Vienna. What is nice, so you have this weighing car here with the sensor technology on the roof, and we have some test charts which are mounted in a real situation on a test pad, and the car is driving by and we're checking the quality which is produced by the sensor systems. There's also a computation for that, so you can look at that afterwards. But to have an insight in these test charts, you can see it here. They are mounted on a pole, and we have one test chart for checking the image quality of the image sensors. And we also have a test chart for checking the 3D data that's coming out. There's also a lot of text written on the test charts. This is the text that's really used on our traffic signs around the city. And you see those photogrammetric signs here. So this is also coming in from an ISO standard where you check the image quality. And in 2017, for the first campaign, this is what came out. So we didn't have these test charts back then, but we checked it afterwards. So you can see that the camera resolution was not really good. You can't read anything. It's hard to recognize it at a certain distance. I think it's 10 meters here away from the test charts. And also for the 3D data, you see that this object, this sign here, is not really crisp. So it was good for 2017. It was really already a step into this digitalization project, but we wanted to have even more. And that's the reason why in 2020 we enhanced the whole system. Now it's a 250 megapixels camera, and you can see clearly that texts are readable. And also for the 3D data, you can see that the point cloud, the laser scan data is much more crisp than it was before. This is really what we're going after. And this test pad and this test charts are really useful to check this. And for sure, we use a lot of standards. For the laser scan data, for example, we use the LAS format, which is standardized. We also have positional information, which is WKT, CRS information, and so forth. So we try to use standards also here in this process. And it helps us a lot to check the quality of the data. And to give an insight how this data then looks when it's produced. So this is in color, you see the point cloud we have to fly through now. And in white, you see the positions where images are acquired. So the images are acquired every 3 meters during life along track. And if you fly through the point cloud, you see that there's a lot of information available. You see traffic signs, you see cars, you see windows. This is just in the laser scan 3D data. And as you can imagine, in images with high resolution, you also see a lot of information. And these data are georeferenced with an accuracy of 10 centimeters. So for us, this is a really good data set to start off to do analysis in many directions. The next one. So after the data acquisition part, when the parts are driven and the quality was checked and everything is ready, we have 2 different pipelines that we use cases. One is to be able to use this data in a really nice way to view on the browser. So everybody should be able to use it in a fair way. So it's a browser-based system, and you can just move through the data. It's really easy to use it. And this is what we call Kapazunda, and I think at the moment more than 2,000 people are using it for the daily business. And the second part is, besides this viewing system, we also want to have this data in a data interface. We want to publish the data for open data so everybody can use it. So remember those more than 100 terabytes of data sets. So it's a huge topic for us to be able to publish this. And also we want to do AI analysis and to be able to push this data to AI systems. So also need a data interface to be able to work with. And we will have a look into 2 use cases now. The first example is this viewer system that I told you, which is browser-based. I positioned myself actually outside here of this room, and which is also nice. It's historic data because it's coming from 2020, and you will see that there will be a logo on the window, which is not there anymore. But I wanted to know the size of the letters actually. And what you can do, you can position yourself virtually in this viewing system. You can have a look around, you can zoom in, because we have good resolution, you can also read the sign here. And here is this old logo MA01. And if I want to measure the length of, for example, the digits here, we can do that, and we can also move around in the space, and we still get these measurements on the correct position. So this means using image data, and we have this 3D data in the back from the laser scanning system. You can measure different things. It's just an example here, but if you measure windows, if you measure buildings, traffic sign positions, and so forth, there's a lot of applications you can do with that. And for sure, there are a lot of standards used here in this application. We have a map here. I think WNTS was already recognized today. We use GeoJSON, for example, to do the classification of the data. We have JPEG for imagery, we have laser scanning data with last formats. So I think a lot of standards go into this application to be able to use it. And besides the viewing system, I mentioned that we want to push the data, open data. The city of Vienna has a strong strategy going public with our data. And we already did this for a small section of the laser scanning data, which is shown in the left image. So this red line here, this is data that is already published. You can find it when you follow this graph code. You will find the image information, you will find the laser scanning information there. But what we saw is there seems to be not really a standard for model mapping data, for storing model mapping data. I asked these questions in the research community that I'm in, and I had 280 views, and basically the answers that I got back is there is no standard at the moment for such complex data with trajectory data, images, sensor information, and so forth. So it seems to be like there are some quasi-standards around, but there's not yet standard defined, and we know that this will be necessary to be able to push it. So open data is one directive that we go into, and second thing that we do with this data interfaces, we do AI analysis. So the city of Vienna has an AI strategy already. You can also find it then afterwards if you go to the QR code here. But this strategy sets the direction of the city of Vienna and what we want to do with AI. So what the city government is heading to. And one of the sections of this AI strategy is computer vision, which actually deals with analyzing images with AI. And because we are a surveying department, we have a lot of image data actually. We do this with this Capozona data that I showed you. Every year we have a flight where we cover the whole city area with airborne data. So there's a lot of data sets available. And it makes totally sense to have an AI system to analyze. And at the moment we are setting up this system in the city of Vienna. And we want to be able to analyze this data for different aspects. Here's a real example of those results. On the left, you can see an image coming from this mobile mapping campaign. And colorized, you see that, for example, here traffic signs have been detected. We also have this zebra crossing, which was detected. So here's in detail. You can see that the AI system is already capable of automatically detecting road markings. We also for sure are interested in road condition, cracks in the roads. So we're training an AI model to be able to detect those aspects. And I think it will help us to be able to automatically analyze the data in a short amount of time. At the moment, this is really time demanding because it's manual processes. And this will help in the future to do fast to analyze the data. Yeah, and that's it for today. Thank you very much. You can use now your human intelligence to read the sentence from the author. And thank you for your attention and being able to send this to you. Thank you.
Do we have anybody from Jugo, from the sponsor of Jugo here today?
Maybe online.
Is Jugo online? Okay, so then we'll proceed to the next presentation. Good. Next presentation is the Graph Integration Platform, or GIP for short. This is an intermodal transport reference system for Austria. Here to present to us today is Stefan Szulinski from Austria Tech. Stefan Szulinski leads the team for data and transport models at Austria Tech, which is a federal agency for the transformation of the transport system here in Austria. He has been involved with the GIP project since 2012, and currently he's leading the new GIP 2.0 client. This GIP 2.0 client will create the second generation of software for the creation, updates, and maintenance of the GIP data in future. Today, he will be stepping in for Mrs. Inga Mandelmeier from the Austrian Institute for Transport Data Infrastructure, who is unfortunately not able to attend today. Thank you.
Hello, from my side. I have the honor to tell you something about GIP, as we call it. And we have some connection already, because with the first speech we heard from Wolfgang Jörg, the network that is in this map, in this basement map, comes from the system we're going to tell you about now. So there's actually an open data product. So how to move it? Clean. Okay. So this first chart is just to give you an idea what is in GIP. GIP is a network graph, like we know from TomTom, like we know from OpenStreetMap. These are network graphs we all know about. And GIP covers all of these things, like the actual traffic infrastructure, inventories of the infrastructure, road surfaces, parking drive infrastructure, whatever you could think of. It is used in traffic modeling. It's used to, the GIP graph is routing capable, so you can use it in transport models wherever you have a routing requirement or something you want to route. It covers public transport, since public transport stalls are there. There's quite an in-depth modeling of traffic regulations, which are traffic signs and floor signaling. Can be used for traffic management, for road safety, for tourism. So there's a lot of applications and the respective content in GIP. I want to just take you through a couple of images to give you an idea what is GIP. Here we see a highway network. It's quite a complex node. We see rural, city roads with secondary roads and municipal roads. We have this multimodal GIP, so we have railroads, quite a detailed data on railroads. But we have just not only railroads, it's also metro lines in Vienna, for instance, tramway lines in Vienna. But there's also other kinds of traffic infrastructure, like ferries, and it's a fabulous place. It's kept somewhere there. We have, I'm losing the word for it, Seilbahn, whoever's there, for me, cable car, but there's also things like walkways and parks. We have, this is something that has particularly we struggled with, because it's not only the roads, but on private property, there's also ways which need to be digitized. Maybe I can show it here, point it here. The information about these access ways is important for emergency services and for routing services, for making sure that somebody who uses a routing service finds the right door of the building, the address where he wants to go to. So this is something we have been struggling for quite a bit, to find these little pieces to make a good routing service and to make sure that the emergency service finds a way to the actual building, to the door where you have to go to. Complex situations like shopping centers, for example, how to cross these shopping centers. Same for railway stations. Are also, you need to have at least a generalized grasp of the interior of a railway station in order to provide a routing service for travelers, for instance, how to find the way to the platform, which is here. But there's other things. I'm just showing you the variety of what kind of ways are there in Austria. This is an alpine way. And what I just want to mention is usually there's always somebody in charge for this way, for this street, for this path. And it's not every time the same. It's a municipality, it's a road and a highway operator like Asfinag. In this case, it is an association who does the marking of this path in the high alpine ways. So we have a lot of agencies being responsible for these ways in Austria. And this shows this next slide. So we have something like ÖBB, which is the Federal Railroad. We have motorways. ÖBB would be a railroad. In this case, this is a metro line anyway. But we have the motorway. We have the secondary roads, which is Vienna. In this case, this is Vienna. We have cities municipalities being responsible for that. We have cycling infrastructure. We have walkways. We have all sorts of entities who are responsible for this information. And the need for the administration to have such a system emerged, I would say, some 15 years ago. And because it's necessary to keep this sort of information, to keep this data available, and to reference to this graph, to this data, as a means of geolocation, georeferencing it to a network. And therefore, it's very important that it's multimodal, that it's redundancy-free. Before the HEAP project started, everyone has its own graph, which covered exactly the content that he needed, like only railroad, or only walkways, or only, and there was no connection. And the difference now with HEAP is that it's all in one place, and it is maintained by those who own the actual infrastructure. That's a very fundamental principle to keep. And it is in one place, it is as redundancy-free as ever possible. And we have a common network graph that we all have access to, that is open data, that is available, and can be used for referencing all sorts of things that happen in an administration, like being at a construction site, or being in whatever you could think of that needs some spatial reference in the network. I think this is just for you. The point is that it is difficult to organize such a thing. If you have that many players around, and you need to get them all in one table. You need to. It's not only data. It's not only software. It's also organization. And therefore, this association was funded, which the members of are the 9 regional administrations, like Vienna and Lower Austria and Upper Austria, and all of these provinces we have heard already. We have the ASFINAG as a member of this association, which is the motorway infrastructure organization. We have the railroad, and we have also mentioned there's an association of cities and towns and local authorities. So we have this all on board. And this seems to be quite an important slide to me, because as I said, data and data standard is only one part, it's an important part. But we have all sorts of cooperation with other entities. We need standardized processes, we need organization, we need software. Software is a big issue. We are about to create the second version of the software. We have HEAP Austria operations who do quality assurance of the datasets and regular exports. From your mentioned, basement comes every 2 months. It's new. One part of it is the HEAP network. So we have a continuous updated cycle. This was a very, very important requirement. That it's not capture it once and then it gets old very, very quickly. it's very important to keep data up to date. And the roadmap network is surprisingly dynamic, especially in Vienna. I don't know how many times directions of one-ways, for example, changed. Even during a year, it's a couple of hundred. This is what the rule says. So that this road network is fairly dynamic. So it's important to have this data created by those who use it in the daily processes of the administration. And then we have a GIP community, which is also important. It's about 45 people coming from all of these organizations who do the daily work with the network graph, who do the maintenance of the data, and who also are very much involved in how the software that we're using for creating and maintaining this data is used, how it looks like, features, how they're maintaining the data model behind this. So it's not only one piece of software and you're fine, but it's much more parts that you need to have such a thing happening over time. Also, you need some sort of legal framework which ensures that things are actually done. So we have a national treaty, which is rather a contract between all of those players, that they commit themselves to say, okay, we need to keep data infrastructure and we fund it, and it is part of our official administration, and it is the spatial reference system when it comes to transfer data. Then we have the ITS directive from the European Union and its implementation into national law. We have Inspire. So this is the basis data for Inspire. This was also a very important driver for this project, that we can fulfill this Inspire obligations. This is also an important driver. So this is also something I want to mention, that if you do something in the administration, it's good to have a legal backing, something that says you have to do it, because then it's easy to get funds for. If you're doing it just out of toying around, it's more difficult. And now I'll take a sharp turn left and tell you something about standardization. What is the context of standardization? I've mentioned we have a lot of players, a lot of people working with this data, and what immediately happens is everyone does it in his own way. Everyone models things in his own way. And very quickly it was identified that there needs to be some sort of standard at least, that everyone is doing the data modeling and the data maintenance and using the data model in the same way. And therefore there is this, I don't know what it's like a standard. It's called FRS, I don't know what's in English to be. But there is some official standard you have to buy, which describes the intermodal transport reference system for Austria and its data model and how to do it. So this is where the link between GIP and standards happens. Besides that, GIP, obviously the software uses a lot of standards, technical standards that we have heard already before. So that's obviously like OGC, and there's a lot of these standards used in the technical. And I want to show you. So this is the official thing, and based on this official standard, we have an internal data standard, because we found out that GIP is a fairly dynamic system when it comes to content. So there's always somebody saying, oh, why can't we put, I don't know, whatever, additional information into our GIP data model. So besides this official standard, there's a fully disclosed, so you can download it anytime whenever you're interested in. And this standard, this internal standard, which is publicized, has an interesting approach. I don't know if this approach is used in other ISO standards, but we have the following approach. First, we have a minimum standard, where we say this is the least thing you have to do in case you're putting into data into if this is the minimum thing, only out this is one wrong. This is the minimum thing you have to put in. Then you have a standard, which is, if you want to do it well, you're fulfilling the standard. And in this standard, there's also other things like remarks for interfacing systems. Like, as I said, the Git data is publicized every 2 months. So there's information about how this publicized information needs to be interpreted, and also other things like Inspire or whatever. And I wanted to show you just this principle. So in minimum, you have to put in, if, like, for example, you are in a regional administration, you have a minimum, you have to cover the motorways, you have to cover the secondary roads, you have to cover all of these municipal roads. You need to make sure that the railroads are in, and there's principal rails and secondary rails. If you want to do it not minimum, but standard, you have to put in all of these other things, which I'm trying to read now, which is far more detailed. You see, there's a long list of things that you should put in when you want to meet the actual standard. And same goes for example, a very interesting part of this is functional road test. Functional road test is something that is used by routing systems. It's a classification on what kind of what importance a road has. This is something that was interesting when we started putting all of this regional data together, and we found out that functional road test was used very differently in various regions. And so the classification scheme had then to be harmonized again because it was interpreted differently. This is also something maybe that's interesting for people who deal with standards. Standards usually try to be as clear as possible, but usually there's still some room for interpretation. And functional road test is something that's an example where trying to make a standard, you're trying to make it as good as possible with examples, with whatever, and then at the desk of somebody who will say, okay, I think it's that one, but it's an interpretation. Another thing that it turned out that the standard is very important and something that really is an important guideline. But in the daily work, the people who do it cannot only rely on the standard. So what has been done usually in this units who work with this, there have been some extra modern rules created, which then provides the actual interpretation of the standard to make sure that everyone is doing modeling certain contents in a certain way. So this is maybe also something that's might be interesting for a standardization organization that we have. We actually have the standard, but the standard then is extended by an actually framework of rules how to actually do it, how to work with that software, which describes there in the bottom. I don't know. It is, that's written. First do this, second do this, third do this, and then you have a secret processing model within the data model. So those 4 steps there below. So I just want to make sure that you understand that standard is important, but then you need also make sure that everyone is doing the steps in the same way to make sure that the data quality is ensured. Product basement, you have already seen that. So the road network is provided there. Here, I think basement I once heard is about 42 layers. Keeps one of those. So we see that it's quite very important because usually most people orient themselves on the map or in real life with road names and with addresses. This is the most important ways of orienting yourself in a place. I would guess, but this is from my experience. Then it is used in travel information service, like this is, I guess, yesterday. Also a national publicly funded service. And we can use it for traffic management. There's of course this is called EVIS, where we try to get all of this road traffic information like congestions and waiting times at borders and all of these sort of things, warnings, heavy weather, whatever, to get in one place and to fill this information to this kind of service. So this is the road infrastructure monitoring side and the way where there is road information as well. What we are currently working on is KEEP 2.0. The software we're working right now is about 10 years or older, so it has reached its end of life. The technology has advanced. We have seen already some examples today. There's a lot of web GIS applications coming up, so there's no more desktop GIS systems. And we want to make sure, that the second generation of software is an open source product, so it can be, it's more transparent. And of course, we're using all of these OGC standard things, all of these things that are in place that help a lot. So to make sure that we build on good building blocks. And that's it. I hope it was interesting. It wasn't really an ISO standard, and I can hardly imagine that the KEEP standard wants to be an ISO standard. Maybe when the software becomes open source and the whole world uses it, I don't know, maybe there will be an ISO standard. But it's just how standards are something that are required for data maintenance, in our case. It's maybe not a very typical standard, but it's important. We found out that we need standardization, and we need detailed descriptions for people who maintain it. So that's it.
Great, thank you very much for a very, very interesting presentation. Now I would like to invite another sponsor for today to the stage from New Marcus, Martin Rieser, and Daniela Thaler-Wolfram.
No, thank you for the invitation to have a short presentation on what we do in the context of standardization. Today I want to share some ideas from our side and our experiences from one of our latest projects in the context of computer-aided dispatch systems in the context of standardization. I don't want to crash a complete system. Okay, thank you. First of all, let me introduce myself. My name is Martin Rieser. I'm an IT expert from the State University of Vienna. And I started working with geoinformation 30 years ago in a surveying company. And okay, sorry. In a surveying company, and my first contact with standardization was also 28 years ago when my former boss told me, hey, there's a Übungsausschuss in Vienna, take part in no time. And I remember some of the meetings also with Northern Partner. We discussed things like the Grundflächenunteransichtspunkt. I had to express it in English, sorry for that. And in these days, I ask myself, what the hell do I ever need an Grundflächenunteransichtspunkt? Ever, never, I will need it. When we had a look at the presentation of the digital twins and all the laser scanning that we do nowadays, there is definitely a good usage for the Grundflächenunteransichtspunkt, where then you can build your digital twin. You can see also the balcony from down the street in the digital twin. So what we do as GeoMagis, we're experts for planning, consulting, and system integration of GIS, special data, geomagnetic, and security application. That's well known from the audience. I know many of you. And therefore, I want to give you for those who are not that familiar with computer-aided dispatch systems. What is this? A computer-aided dispatch system, CAD. Don't mix it up or mix it up with computer-aided design. Are systems which are utilized by dispatchers, call takers, and minor level operators. They prioritize and render incident calls, identify the status and the location of the responders in the field, and effectively dispatch responder personnel. So you see, identify the status and the location. So we have a very close connection to GIS and geographic information. So you will never find a modern computer-aided dispatch system which has no core GIS functionality, like mapping, location verification, routing, for recommendation of units. And one of the essential things in those systems is you always need to have up-to-date spatial data. It's not good if you have a system where you have all the streets and the addresses which are new for the last month or the last year. You have not in your system, so you can't find the people outside. Okay. When we look back 25 years, when we had our first project with the Vienna in Austria, and we had a look on the former software systems which are used for dispatching. They had no standard GIS components. Spatial data is stored in their own proprietary database. Web display is only used with web files or only raster files. They have local coordinate system, no WGS like before something else. So it was very complicated to collect the data, doing the workflows, ETL jobs to bring the data into the systems, and then you have the next challenge doing the updating. So that's really a very hard job. And if you come to now, we started the project in 2020. And we discussed the project. It's a German police department. And they say, okay, we want to go another way. We want to split up our complete system. We want to change the complete technical infrastructure, including the software systems for the dispatching. And we want to build our own GIS, and we want to have it separated from the dispatch software. And we want to use services providing the functionality of the GIS and all the functionality we need for the dispatching. So it was the first idea to completely separate the dispatching software from the GIS functionality. The challenge was, okay, how can we do that? We were not sure if it's possible. And what if you remember when we think back 3 years, I think, when we got the ecosystem for the Austrian police, when we discussed to provide the basement in raster tiles because they cannot consume the WMTS services that you provide with basement.it. So we were not sure if there are systems out there on the market which are able to consume services. Maybe a very funny question in days like these. But when we did the research, we found out that many systems still do not use standard GOS components. They have their own clients. They are not capable to using web services. They are mostly not capable to using location services, routing services. It's a very own infrastructure that's built in these dispatch systems. So we thought, okay, what shall we do now? And we asked ourselves, what are the reasons for that? We found out that besides that dispatch systems are part of a critical infrastructure, these projects have a very long implementation time, for at least 2 or 3 years if you have an initial implementation. If you have a renewal project, it also lasts for 1 to 2 years. Those software systems are running at least for 10 years, so the development cycles are very, very long. So it took a very long time for new technology and new ideas to come into the project, into the products itself. So that's one of the main reasons why most of all dispatch systems, which are still up and running outside, have no possibility and no capability to use GIS standard-side services. So we had the challenge. We have a lack of software on the market. So how can we achieve the goal that we want to have a separate GIS, providing services, providing data in a standardized way, which is responsible itself for the complete updating and editing of the spatial data sets. And on the other hand, we want to acquire a computer-aided dispatch system, which is able to consume that services. Our idea was, okay, we have a tender, and the requirements for this tender will say, okay, at least it's mandatory that you will have to use map services, and it's optional to use other services like routing, like location verifying. But your tender gets a better rating if you use even more services. We are not sure if that will work, but the result was that all bidders at least promised to implement for that project the usage and the addition of the capability to use the services that we provide out of the GIS infrastructure. And most of the bidders even presented a proof of concept of the implementation of the usage of the services. So it was a very good result at the end of the day. And our conclusion on this point is that it's not enough to define standards. You also have to make them available. And not only available in technical point of view, but also on the market. And therefore, we also need forerunners. We need vendors which are willing to enable the systems. We need customers with the awareness of the advantage using standards. And we also need planning offices and consultants supporting that vision. We need additional, sometimes creative methods in convincing the market. And that's our work that we will try to support standardization to get a broader awareness on the market in the special case of computer-aided dispatch systems. Thank you for your attention.
Okay, we have heard so much interesting presentations this morning, and we are actually at the end of our services based on GIS service standards. And actually, we're supposed to have a discussion now. I would really like some of you to ask some questions. I do have some questions. I wanted to ask a question about Kabatsunde. these images, how do you actually? It's only provided by Vienna, by your own vehicles. Is there any possibility for other people to also provide data? Have you thought about that? Or maybe you can come to the stage and answer.
Good question, by the way. Yeah, we thought about that. We had discussions, you know, there's a big player on the market, so there's mobile mapping, which is Google, obviously. So we did big discussion. It's impossible to take other data, it's already real, it's real. There are two things. Quality georeferencing that we do with 10 centimeters, the position accuracy is really mandatory to be able to use this data then for GIS analysis. So if you would take other images, you need to ensure that they have this position accuracy. And in most cases, it's not available, not for Google, for example, because they have another approach. But you could use another company who has mobile mapping, who has the sensors and editing. Actually, we don't own these powers. There's a company doing it for us, and that's the reason why we have this test bed. We do a tendering process, and there are different systems on the market with different sensors setup and so forth. They have to cross this test bed, and then the sensor system wins. It's price range, it's about sensor quality, and then we take the data in, and then this interface comes in place. Use the data. So for us, it would be possible. Yeah. As I showed you, we have two campaigns. It's two different sensor setups, two different companies. Next time, maybe it's another company as well. And we are also thinking about doing our own system to be a little bit more flexible, because those campaigns are carried out every 2 to 3 years, actually, because it's rather a big project. But to be flexible, to have a high frequency in collecting data, we're thinking about doing our own system, which will be also a different sensor setup. So this is possible. We are not so far that you can send your cell phone images or something. That's also something that might be possible in the future. One more sentence, there's another aspect, it's anonymization. All these images show people, show license plates. The data needs to be anonymized. That's also a critical part. If you take data from somebody else, this is something that needs to be of. But yes, we are able to take data from different systems.
Another question that, well, what interests me really is this artificial intelligence, and how do you actually train an artificial intelligence system to realize that you have like a problem on the street where some of the roads are brittle, or you have some damage. How does this work? Because as I understood, you have to train an artificial system by hand. As you have to tell me basically what you can explain to people in the audience how that works.
Yes. Artificial intelligence, one of the most demanding tasks is training the data. Otherwise, after that, you need processing hardware, you need some knowledge about IT systems and the quality that then occurs. But in the front, you need to train the systems, as you mentioned there. Actually, with artificial intelligence, it's like training a small kid how a cat looks like. What you do is you show these small kids different images of cats and books and so forth, and you train the kids to realize this is a cat. The same way is for geodata. If you think of road cracks and you want to identify these, first of all, you need a catalog saying, okay, this is a road crack, this is a marking, whatever. And then you need training data. You take samples out of the data. It can be from the mobile mapping campaign. You also feed it with images from cell phones. And you need trained staff who knows, okay, on this image, I as a person see a crack. And this crack is then marked up in the image. So it gets digitized and it gets classified. This is a crack. For example, for the classes that I showed, we get 6,000 images with trained staff knowing a lot about traffic signs, about road damages, and they do. And this data. Yeah. So the training section. There are some changes. So if you listen to us, please mute your microphones. Okay, now it's done. So we take the training data which is marked up with the images. This is then put into the AI system. It's trained, so you need processing hardware, you need some power. And after that, you apply the trained model to the rest of the data set, which was not used for the training. And then you get results, and you need to look at these results, but some might be good, some might be bad. You need to retrain. You need a loop of quality check. But at a certain stage, the AI will be capable to detect objects. And as you saw for the traffic science, you don't need so much sample data because traffic science is really standardized, so again, on standards all around the world because we are driving in our holidays and we recognize if there's a traffic sign. So you need some training data for traffic science. It's not that much for one class. Sometimes it's enough if you train 10 images. That's it. For cracks, it's much more difficult because cracks have a different appearance. So you need much more data. It's hundreds of images. And that's human power, that goes into human intelligence to train the system. Remember the kids you showed the cat. We train the system how these objects are in the images. And what we do then as a surveyors, we know how to put this data, which is in 2D images, into 3D space, and then these spaces can be coming. But for the image detection part, it's just showing the AI system examples of images showing those classes. It depends on the use case, how many data it needs to be trained to do. But it works fairly good actually. Yeah. It's amazing. And the AI is everywhere around, also in the geo sector.
Good. And then we have two questions from Mr. Stefan Strelinsky. The first question, you have this software that people can actually put their data in. Is it always, is there a specific software platform available where the different Austrian entities put in the data? That's the first question. And the second question, is there a central point where somebody can actually tell you, or so as we say in German, eingaben, they can actually report when there is something wrong and some streets are not correct?
Yes, to both. So the first thing is that the software that we are now replacing, this is more than 10 years old, is strongly rooted in the ArcGIS product world. And there has been some extensions programmed on the Arc Azure products suite for managing this data, putting this data in a structured way, and for viewing it and this kind of things. So this first iteration, the first 1.0, and now since this software has grown old and Azure has also moved on and has different products now, we have decided we need a new version of it, and we thought to address the market. I think basically we will go and try it with an open source solution that we are currently under development. So we had the first tender is out now, the first project is so the server component of the software is now being developed. And we are starting with tendering the client software part as well. So these parts are, and there's an important thing to mention. The technology has advanced, especially in this web GIS technologies, plus the standards are available now, because we've heard a lot about these technical standards, and these are all standards we use. We use VMTS, we use UTF, all of these standards, all of these OGC things, we use all of these standards. And they are available and they are open source, and we can use software that is available. So this is one thing. And yes, regarding this data system issue, what would you call that? If somebody found an error on the map, yes, there is a reporting system for that, which is called Keep Communicator. It is semi-public. I'm not sure how public it is, but it is used for the internal
things, but there are means. I think it's on Geoland, for example. There's an interface where you can put in. So there is a website where you can put if you found an error in the map, you can report it via a structured process, and this is tricky again because we have a lot of actors. So we need, if somebody reports an issue, we have to identify where is this issue, who is responsible for taking care of this issue. So these distributed systems bring their own the challenges, and yes, but there is something like this, and we have like requests coming. I don't want this road to be in the map because this is my primary road, and I don't want everybody to know about it, and all of these sort of things come along. So yes, there is an interface with the public.
Do we have any more questions to Mr. Sileski regarding the gift data? Thank you. I do also have a question about the digital planning twin, the planning twin and the geo-twin. She was just mentioning when we had a coffee break that they do get data in different formats. And I would like to explain to us how they actually, from whom do they get all these data, and how does she actually transform all of this data so it makes sense, so it fits into the model.
Maybe we have to differentiate between the geo-twin and the planning twin. For the geo-twin, as I mentioned, we get all the measurement data from our department. It's coming from terrestrial mapping, from granitory, mapping systems, where we have some evaluation of the point clouds that can be measured. And there is an additional project in our department where we actually try to put all the data from all departments that we have at the system mapping to one simple data model, and that will be the golden source for our geo-twin. So we have all the measurement data from all departments together in a data model, and that's our source for the modeling of the geo-twin. And we additionally also take point clouds for the modeling, and the better or the correct information that we gather from that, we go back into the central geo database so that we have the accurate data. And with the planning data, the thing is, the planning data is not created by us as a link department, but we get the planning data from the planning department. And there it's often the case, as I mentioned, there is a big variety of 3D formats. That's why we need to use the ETL transformers to get it into a 3D viewer, for example, or to get it into a central database. And the main problem here is that often these formats are not georeferenced, so before you can use it, you need to georeference it. Or in many cases, the data is also only available in an analog form, so you have to digitize it. So the biggest step with this planning twin is really to make the data available for our virtual data, which is integrated.
So a lot of manual.
Yeah, it's manual work, as there is not the standard for 3D data, especially because there are these different stages.
Okay, thank you. Thank you very much. Do we have any other questions about any other project at the moment? Yes, sorry.
Thank you. I would just like to say a few words. My name is Agneta Engberg. I am the predecessor of the current chair of ICT Institute at Computer Parks in the UK, and I'm from Sweden, and I'm the successor of the first chair, Olaf Östensen, who was presenting earlier this morning. So just to say a few words of thank you, I think it's been a very interesting morning here, very high quality presentations, and I'm pleased to see that so many presentations also address the fact that it's not just about standards. It's the environment, like the domain, I mean other aspects like legal or governance and so on, and also technically it's not just about the standards, because we need to actually look at the details and make the standards we will use. I really appreciate this. But if I may ask a question to Sarah, I think that, I mean, I don't think you need to be like me, born in the 50s or been sleeping the last 10 years, but I mean, there's a lot of new words and concepts. And could you, in a simple way, say what does it mean to be a digital twin? I mean, what's the difference between a twin and just a terrain model or database or CTG map? It's just, do you have a sort of digital twin for dummies? I mean, I can understand, and I think it's a fantastic thing you present here, but it's just about the concepts and terms, and
Actually, we have this discussion quite often. So what is a digital twin?
By me then.
Because you read about digital twins everywhere, it's in the industry, and often digital twins are also presented in a form of only visualizing, like a 3D mesh. In our interpretation, a digital twin really is a semantic and intelligent representation of the reality. And in this case, as an urban digital twin, of course, it has to be the representation of the city. But furthermore, it's not only the geo aspect, but many more use cases, as I mentioned before. And we are not only working on a planning twin. Currently, we are in the process to start building up a digital twin of the city of Vienna. That, of course, takes a lot of time. But a digital twin of a city is so much more. You need to connect systems, you need to connect data sets. One big topic is the linking of the geodata with the corresponding department data. Like we have the geometry of buildings, but there is also information regarding the building, which material is built of, or the same goes for the streets, vegetation, and so on. And for us, the digital twin of the city is really if you connect all these systems and try to make this intelligent platform that can then deal with all kind of analysis, simulations, and so on. Yeah. Makes sense. Yeah, so I think in a sense, what Sarah is also saying is that the digital twin is very, very important for the smart cities, because we will not just, it will not just help us to look at a digital twin to maybe find our way when we go there in real life. But in the end, smart cities have to connect all different systems with each other. And then the digital twin will, of course, play a very, very big role. Are there any other questions or remarks? Good, then we have a good time. I do see there's a big sign here that we have a photo.
Oh, there's a change. The photographer isn't still arrived until now, so I would say we take the lunch.
What is it? I was waiting for my Good, so we'll have the photo maybe later. At the moment, we have been another break. It's another 15-minute break. And this time, please, all proceed to the room where we have sandwiches and snacks and coffee. And we'll see, we'll meet again at 12:30. Thank you.